On the domain-based experience, I have worked in banking and energy services domains, and my passion lies in learning and understanding the recent trends that are there in BI and analytics space. I'm also learning R in my free time, and along with that, I love to spend my leisure time reading books, watching movies, and following European football. I'm a die-hard Manchester United fan. So let's delve into the presentation now. And before going into analyzing the details about ETL and its future, let us understand what is the role of ETL in BI. What exactly is BI? So BI is basically business intelligence, and it refers to technology, applications, and practices for the collection, integration, analysis, and presentation of business information. So splitting that business intelligence is more like this technology gives us the intelligence to understand the business. So BI systems are essentially data-driven decision support systems and provide historical, current, and predictive views of the business operations. So that, in a nutshell, is what BI is. And now that we have a basic understanding of what BI is, let us see what are the components of BI systems and where ETL comes into the picture. There are 4 major components of BI systems: data management, transformational tools, data repositories, and analytical tools. And these 4 tools come together with equal weightage to form a BI system which supports a business and its data-driven decision-making process. So I'll just go through a few lines for each topic to help understand what each means. Data management is basically managing the data that is generated by a company's day-to-day operations and transactions. It is critical to enable organizations to draw meaningful insights from it. One of the key challenges of data management is data integrity. Now, data integrity, it means that, let's think of a bank and it has my account details, and every time I do some transaction on my account, that gets reflected onto my account wherever I access it from. So that is data integrity, maintaining the same account of a particular entity, maintaining the same details of a particular entity throughout consistently. That is data integrity, which is one of the biggest challenges of data management. Next comes transformational tools. These are the tools that the required data need to undergo manipulative processes, which include data extraction, cleaning, logical and or computational transformation, and finally data loading into target data warehouses, also called data repositories. So these transformational tools are what makes the data ready to use. We get a lot of data. Think of a turbine generating data. That's a huge about wear and tear, about what is the RPM of the turbine and everything. But not all of the data is really ready to use and to draw and get in. So we need to modify that data. This is where the transformational tools come in specifically. The transformational tools are that we'll examine further down the road. Data repositories. Organizations store the data in data warehouses. These data warehouses, which are basically partitions of these data warehouses to handle single business functions. There are also metadata repositories which are used to store data definition and technical information. So data repositories are the places actually store all of that data that is coming in from the data management stage to the finally it enters the data repositories. And from the data repositories, it goes on to the next component, that is the analytical tools. So there are a lot of extremely popular analytical or visualization tools in market right now, like Power BI. We have ClickView or ClickSense, and then we have SSRS, and we finally have Tableau. These are some of the most popular tools in the analytical and visualization tools in the market right now. So these tools are basically used to generate analytical insights, which help the organization to spot trends anomalies, and other critical points as a result of their transactions and operations, and help chart down the further action plans for the organization. These tools are the ones that are used by the management level executives to identify what is going on in construction. So these are the 4 basic components of the BI system. Without going into further details about all of these components, lest we deviate from the original topic of this presentation, we'll henceforth restrict our discussion to the ETL studies only and study the reasons why and how ETL became an inseparable component of all BI systems, and gradually examine the future prospects of the same. So, what exactly does ETL mean? A lot of people out there already know what it means. Of our audience who are not accustomed to the BI process or ETL, I'll just go into a brief description about ETL. So, ETL, from a qualitative standpoint, is just extract, transform. So, to expand ETL is used basically to extract the data from various data sources like their databases, flat files, or transform the data into business relevant format so that it's ready to use, and finally load it into other targets like databases or flat files as is the need. However, cliched as it may sound, that one is just the tip of the iceberg. In reality, ETL technologies help perform so much more. As you can see on the screen, we have data integration, data transformation, data encapsulation, data cleansing, profiling, increased performance of reporting, reduced need for complex programming languages like PL SQL. So each of those functions are critical parts in making that in making the entire BI system ready for analysis, for analytical purposes. And ETL, by combining all of these functions, has played an integral role in helping businesses all over the world making sense of their data and generate insights. For close to 5 decades, it has remained a bridge between all data sources and reporting softwares or visualization dashboards. However, with the advent of analytics, data science, and cloud technologies, there is a pressing need to reevaluate the need, if any, of ETL processes further down the line. Also, we need to understand what are the major challenges facing this legendary technology. And in our attempts to find answers to the above questions and we formulate a roadmap, which I hope we will be able to do by the end of the presentation, we need to first understand how big are the organizations betting on these new technologies. We are hearing this hue and cry about big data, data science. Almost all companies want data scientists and all. But how big are the organizations really betting on it on a global scale? Let's look at some figures. So, as we see, a survey of executives from Fortune 1000 companies revealed that 48.4% of them are achieving benefits from their big data investments, with over 80% characterizing that these investments are successful. Now, this is a survey of some Fortune 1000 companies. So these are some of the biggest companies on the planet, and to have almost 50% of them admitting that they are getting returns from their big data investment, that speaks volumes about this particular technology. Again, as of December 2017, approximately 53% of companies were interviewed as part of this 2017 Big Data Analytics Market Study by Dresner Advisory Services. And they said that they are adopting big data. And this 53% figure has risen up from 17% in 2015. So that's almost a 300% growth in the last 2.5 years. Almost 60% business leaders believe that failure to get on board with big data and analytics could lead to obsolescence. And there's justifiable understanding to this. Big data and analytics has opened up an understanding of the business like never before. Nowadays, companies can generate so much data about each of their transactions, understanding their customers at a level never possible before. I mean, any company that does not come up to that level to understand their customers, to understand their own operation, it's going to be hard to compete with the data-driven companies. Revenues generated from big data analytics market are estimated to cross the 210 billion mark by 2020. And finally, over 90% of companies claim to use some form of cloud computing. So as we see, these are figures that demonstrate a clear upward trend in investment about data science and cloud computing. And we really have to understand that going forward, how is this change and how is this upward trend going to affect the BI space as a whole, and whether will BI survive or whether will BI get dissolved or remain as a part of the entire data science and cloud computing process. It's safe to infer that analytics, big data, and cloud technologies have got a majority of organizations undertake massive efforts to become more data-driven and decentralized in their efforts to gain a significant competitive advantage. One question, however, that arises here is, how is business intelligence different from business analytics? Well, according to experts, analytics is basically divided into 4 categories. We have descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. And BI falls in the descriptive phase, where it offers insights into what has happened, with analytics anticipating what will happen under various future scenarios. So the primary difference between BI and business analytics is that BI focuses on the past and business analytics focuses on what may happen in the future, what could happen in the future. The predictive capability, this predictive capability is what makes analytics so powerful to businesses today. And while reporting and visualization software providers like Tableau and Qlik have already integrated predictive capabilities to their offerings already, the ETL industry as a whole has taken a relatively longer time because of a number of challenges that we are going to talk about in the next slide. So there are some legitimate challenges that we are facing, and they are heterogeneous nature of the data. Well, previously we used to have only one type of data, that was structured data coming from Excel files or DBMS like databases. We have those rows and columns, and we have the data fit in there. So that is structured data, and it's easy to handle that, process that. But now comes the next tough level, that is the unstructured data. Files like JSON files, XML files, the format is within tags, and within tags there are multiple nestings done. So it's a semi-structured format. It's not in a tabular format, and hence we call it the structured data. And then comes the most complicated form of data, that is unstructured data. We have audio clips, we have PDFs, we have images, we have customer reviews posted on social media or even on the website. So these are all unstructured. We do not have a particular structure to understand, to even process or parse this data. So that is one of the biggest challenges that ETL has faced till now. The next would be real-time data analysis. Now that there is a much more pressing need to have data handled and processed real-time to get the insights then and there, rather than historical processing of data or batch processing of data as we know it used to be the case even 5 to 10 years back. So executives today can't wait for the batch load or the ETL job to run 24 hours down the line to be able to get their hands on the data. They want everything now within a 5-minute or a 15-minute period. So this has become a challenge to continuously do this data processing on a real-time basis. The third challenge is integration into cloud technologies and big data along with traditional RDBMS. Now, because cloud has come in, because big data is still coming in, we cannot, neither can the organizations just ignore the RDBMS, the older data that they have. There needs to be a way to integrate both of these systems, the older structured format along with the newer structured plus semi-structured plus unstructured format, and that too in cloud. We had While cloud computing, I focus less because there's a lot more adoption to cloud. But yeah, big data storage and analytics is where the greater focus throughout this presentation will be. Which brings me to the next point, that is handling the 5 V's of big data: volume, velocity, variety, veracity, and value. All of those terms are pretty much self-explanatory except veracity, which means trustworthiness of the data. So we have to make sure that the huge volume of data coming in at rapid speed, we are generating, some organizations are generating terabytes and petabytes of data every minute. And then there's a variety of data, as I said in the previous point about unstructured, semi-structured, and structured format. And finally, find the trustworthiness of the data. Data integrity has to be kept intact. In the process of doing all this, we cannot let go of the data integrity. And finally, what value the data adds to the business. So cumulatively, these are the main challenges that are faced by the ETL process today, and overcoming all of these challenges is definitely a Herculean task. What we will do here is explore a roadmap for the ETL technologies to adopt to these challenges going forward. While some of these solutions are already being adopted across industries gradually, some others are still yet to come into widespread adoption. So, while exploring solutions, we have 3 most potent solutions that we can take. The first is going for an ELT approach instead of an ETL approach. What is ELT approach? Well, we'll come into that in a moment. The second is data vault instead of traditional data warehouse. And the last is the additional big data compatibility. So let's explore each of these options one by one. So ETL is basically the traditional process where we take the data from the source, we put it into a staging or an intermediate area, then we transform it and load it into the final data warehouse, and then that data is finally available for analytics and analysis purposes by the report generators and other BI users. And using this ETL process, analysts and other BI users have become accustomed to waiting, since access to the information is not available until the whole ETL process has completed and the data is present in the data warehouse. In ELT, however, we load all of the data immediately after extraction into a single centralized data repository in the cloud. Here in the diagram, you see the Hadoop is basically the storage where we are storing all the data first, we are loading the data, and then we are transforming it. So, since transformational activities are done after loading, the waiting time for analysts and BI users is greatly reduced. It helps in that real-time analysis a lot because we are saving a lot of time. Additionally, without the need for staging areas for ETL, the loading and maintenance times are also greatly reduced. We are having a one-step loading process here as opposed to a 2-step loading process previously. So ELT is a very solid approach going forward over ETL. And the second solution would be a data vault. So a data vault is basically a methodology with hybrid data modeling, where we encompass the best breed between third normal form and star schema. The design is flexible, scalable, consistent, and adaptable to the needs of the enterprise. The data vault blends consistent integration of big data technologies as well, along with the more orthodox modeling, methodology, architecture, and outstanding practices. Through this adoption, very large amounts of data can be easily incorporated into products like Hadoop, MongoDB, etc., which are basically the underlying essence of big data. And once the big data vault model is ready, ETL data integration process can be used to populate it. Or even we can go ahead with an ELT approach as we discussed previously. And the last solution, which is becoming very popular now, is the additional big data compatibility. So what the established players are doing, they are just coming up with big data compatible software updates for their existing software. Like we have ODI and we now have ODI for big data. We had data stage, we now had data stage big data. We had Informatica, we have Informatica BDE. Talend, we have Talend BDI platform. So similarly, so these tools have come up with these solutions by transforming so that we can transform the unstructured and various other data which can be used in analytics. And these are some ready-made solutions where we don't need to go for a complicated POC approach, and we can just and this process has enabled these ETL technologies to be able to compete even in this changing data science and analytics scenario. So adopting one or more of these solutions will be sufficient to handle the challenges posed by the unstructured and big data landscape. However, as we conclude, we see that ETL continues to remain an intrinsic part of the data-driven decision-making process. While it has to adapt to the methodologies to a changing ecosystem and the nature of the data available, ETL or ELT, as we call it, will be of utmost importance in the upcoming days of data science, analytics, and cloud. And with that, I want to bring it to an end, and I want to take a moment to thank our sponsors, the Association of BIKON, and also for Anup for providing me the opportunity. We can move on to Q&A round now.